Okay, good morning, everyone. I hope everyone is joining. This is the most important part of our lesson today about the methods of integration. Maybe I would wish that everyone can, those who have managed to join, you can copy the link and send it to your colleagues who are still maybe not managing to join directly. So just please copy the link for us, those who are able to copy, and then you send it to your colleagues. Uh, yeah, good morning to you too. Okay, I hope you are able to see what I've beamed, which has been displayed on YouTube, including on. And I hope everyone is following. Please, if you are following or if you're able to hear me, then you can just say no, we're able to hear so that I can start the class so that we don't waste a lot of bundles waiting for those who will be coming in late. Please, if you're able to hear me, you can say we're able to hear you. Okay, that's great. Okay, all right. Then we can start. All right. So today we are going to look at the methods of integration. So we are going to start with, okay, there are other functions, just like you remember last time when we had functions, there are those functions that were unable to find their derivatives. So as such, we had find means and ways, for example, where we could use the basic ones, methods of differentiation. So we had find means and ways to on how we can find the derivative of those functions. It's where we are now employing the methods of the chain rule, the product rule, and also we're employing the method of the quotient rule. And we are also employing the methods of implicit differentiation. So with such, even also under integration, there are other functions that we can't integrate directly using the formulas that I mentioned last time. So to do that, the method that you can employ are these methods of integration, of which the first one is what we call the substitution method. Now, this substitution method, it has got three categories. There's a situation where you substitute algebraically, so algebraic substitution, or the other one is where you will substitute trigonometric functions, at times where you substitute the hyperbolic functions or the trigonometric function tan of theta over 2. Then the next method of integration is the one that we call integration by parts. Then the other one is where you use partial fractions. So it's a situation where you are given this rational function that you can't integrate directly, but instead you need to split this function into partial fractions. as such, when you split it into partial fractions, then you integrate. So the expression becomes easier. The integration process becomes easier when you split it into partial fractions. And then the last one is the reduction formula method, which we are not going to do as at your level. Those will be proceeding to second year. You're going to do this method. Okay, so having said that, I'll be beaming just as usual. I'll be showing you the board where I'm solving. Okay, so mostly I'll be solving on the board. So I'm about to beam the board. So now if you look at the substitution rule of integration, this one basically corresponds to the chain rule. What was happening when we are dealing with the chain rule? We are saying let u be equal to this. That's what we are saying. Maybe let me just open it. Let me open to the let me use the board. Okay, now if you recall last time, what we mentioned is that if you have, for example, a function y which is equal to maybe 3x squared minus 4x plus 1, maybe to the power 10. So what we are doing when you are differentiating is that because you can't multiply, it's very cumbersome to multiply this function by itself 10 times. That's when you differentiate. Instead, we are using this the chain rule, where we're saying let u be equal to 3x squared minus 4x plus 1. So this is what you are doing. So this is a kind of substitution method under differentiation. So the chain rule method of differentiating functions corresponds to the substitution method. This corresponds to the substitution method of integration. And the other one, the product rule for differentiation, this one corresponds to integration by parts. So these are the two methods which corresponds to those which are involving the differentiation method. Okay, now, so the first method of integration that you're going to employ is the substitution method. So the substitution methods of integration. The first question that I need to ask is this. Under the chain rule states that, I hope you're able to see what I'm writing on the board. Please, if you're able to see, you can say we're able to see. Otherwise, I might be writing and then no one is following. If you're able to see, then just tell me you're able to see. Okay, now, what does the chain rule first states? The chain rule for differentiation states that if you have a function so if we have a function y which is equal to f of g of x, okay, then if we have a function y which is equal to f of g of x, then the derivative with respect to x of this function f of g of x, we said this is equal to the derivative of f of x at g of x multiplied by the derivative of g of x. So this is what the chain rule states. Now the question is, from this chain rule, how does the substitution method for differentiation now comes in? So what you're supposed to do now here is that now the differentiation rule, this is where now we have the theorem. Please check from your notes. Check theorem number 14. what the theorem number 14 says is that now, if so, under the chain rule, what you usually say, if the function y is equal to f of g of x, so what you were usually saying is that you were saying let u be equal to the g of x. This is what you were frequently saying. This is what you are frequently making this. You are frequently making this assumption to say let u be equal to g of x, and then from there now you start finding the derivative, of which it was then the derivative with respect to x of the function y was equal to the derivative with respect to u of y times the derivative of u with respect to x. This is what you are frequently doing. Now, under the integration method, so what we are saying is if you have a function, if u is equal to g of x, just like the way you stated it, if this function is differentiable, if u, which is equal to g of x, of which is the function that you have to equate to g of x, when you are doing the differentiation using the chain rule method, so whose range is the integral? So now, if this function is differentiable, whose range is some interval I. So whose range is some interval I, and f is continuous on I, and f is continuous on this same interval I, then what happens is that the integral, okay, so the integral of the function f of g of x times the derivative of g of x with respect to x, this is just the same as the integral of u with respect to u. And also the integral of g prime of x over g of x with respect to x. Oh, sorry, this is f of, okay, so this is going to give us the integral of 1 over f of u with respect to x. Okay. The proof will be left as an exercise. This is a part of your work. I hope you are all following. All right. Okay. That's great. Now, let's look at the procedure for differentiating using the chain rule. The procedure for differentiating using the chain rule. So there is this simpler way that I need to explain to you on how you can recognize to say what this should be my u, or this should be my the derivative of u with respect to x. So the choice here is, how can you determine what the choice here that is so critical is the choice of u. What should be your u? What should be your u in this theorem? So, for example, you have this theorem of this nature. Then they are asking you to differentiate it with respect, to integrate it with respect to x. The question is, how should you know this should be my u, so that when I integrate, this will vanish, and then I'm going to arrive at my answer. So this is one thing that you should always bear in mind. Okay, now let's look at some examples that involves the same substitution methods of integration. So what I'll do, when we look at this example, I'm going to go back to the procedure. I think every one of you has the procedure, because if I just mention this procedure without writing an example, it will be very difficult for you to get the concept. Okay, now so let's look at the procedure. Okay, let's look at some example. That is example number 14, should be 14 in your lecture notes. Please check your lecture notes. Example number 14. This example says find each of the following. The first one is the integral of the square root. Okay, I'm going to use x here. There are 4x minus 1 dx. The second one is, by the way, some of the examples, you have them in your notes, so some of them I'm going to skip them, of which you need to find time to go through them. So the second one is the integral of 4 divided by 5x plus 3 with respect to x. The third one is the integral of x squared times the sine of x power 3 with respect to x. Please, the choice for you is very important in these questions. If you make a wrong choice, then just know that your solution will also be wrong. So once you make the wrong choice with respect to you, you'll be stuck in as you'll be solving your solution. So I'll write the fourth one, which is the fourth question, which is number 4, which is the integral of the sine x to the power 5 multiplied by the cosine of x dx. Okay, we have these questions already in our lecture notes. As such, we don't need to say, no, I don't have these questions. So every one of us has these questions. Okay, now let's look at the solution. And please, each one of you, so we are looking at, we want to integrate the square root of 4x minus 1 with respect to x. So one thing that requires, the question is, one thing that requires you to integrate using the substitution method is that a situation where you have failed to integrate that given function directly using all these other methods, all these concepts that you've learned, all these basic concepts that you've learned. Now you have failed to employ them in finding the integral of that given function. That's when now you can think of using substitution, or you can think of using integration by parts or by partial fractions. Now, let's look at this question. Maybe I would love each one of you, if you have opened your notes, please, let's go back to the procedure. The procedure says, substitute u, which is equal to g of x. So you substitute u, which is equal to by g of x. So where is g of x to substitute u? Now, in this question, which one is our g of x? Okay? So if you look at this question, this is just the same as the integral, okay, 4x minus 1 to the power half times, dx. This is how this question is, again, is just, so you can also rewrite it in this form. So if you look at this question, this is f of g of x. So because we can't differentiate this directly, we can't integrate it directly, so we employ the substitution method, which is related to the chain rule. Now, here, what you're supposed to do, you're supposed to say, your choice for u is very important, like I mentioned. When you're choosing u, you have to be careful. Okay, now, in this case, we say, if we let our u be equal to the entire function, So then we let our u, that g of x will be x minus 1. Now, once you substitute where there is for this function of x by u, it means that you are also supposed to substitute, you're also supposed to replace this d of x with d of u. Okay? So now, how can we do that? How can we replace this d of x is, now, if you let u be equal to 4x minus 1, then your du dx will give us what? 4, isn't it? That's because the derivative of 4x with respect to x to be 4, the derivative of negative 1 will be 0. Now, if you look at du dx is equal to 4, we can, this is the same as, you can also write it as du dx, oh, sorry, not du dx. You can also write it as du is equal to what? 4 times dx. This is how you can also write it. Or you can simply, because the issue here is we want to substitute where there is dx by something that has got to do with du. Now, how can we do that? That means in this equation, we need to make dx the subject of the formula, or we need to solve for dx. So if we solve for dx in this, this is the same as dx is equal to du over 4. Okay. Hence, so then when you do this, then you say, okay, thus, after you have done this, thus the integral of the square root of 4x minus 1 with respect to x, which we have said, this is the, which is the same as the integral, open bracket, 4x minus 1 to the power half with respect to x. So now, this integral now is the same as where there is 4x minus 1, we substitute by u. So we are going to have the integral of u to the power 1 over 2. Hence, where there is dx, we substitute it by du over d, because dx is equal to du over d4. So this, I mean, over 4. So this is, we put du over 4. Please, I'm going to rub this part. Okay. Then this will give us the same as 1 over 4 times the integral of u to the power 1 over 2 du. So now we integrate with respect to u using, now if you look at this u to the power half, you are able to integrate it using the concepts that you learned at first. So this is now, so this is equal to 1 over 4. Now the integral of u, this is just times u to the power half plus 1. This is what we are doing last time, over 1 over 2 plus 1. Then plus c, which is the constant of integration. So this, when you simplify, you are going to get 1 over 4 times u to the power 3 over 2 over 3 over 2 plus c. Please, when you do the simplification and modification, what you're going to get is u to the power 3 over 2 over 6 plus c. Okay. Now, this is what you're going to get. Now, the issue is, what is your u? But what is your u? When you started, you said u is equal to what? 4x minus 1. So where there is u now, you substitute with what you started with. So this is 1 over 6. Our u is equal to what? 4x minus 1, everything to the power 3 over 2, then plus c. So you are done with the construction of your proof. I hope everyone is following. I hope everyone is following with my construction with the solution that I've illustrated on the board. Okay, please, you can just type that you're following so that we can be together. If you have questions, you can just type them. Still, I'll be able to see. Now, So this is the end of the question. If you want, you can rewrite this in whichever form, which is just the square root of 4x minus 1 then the power 3, or the other way around, which is the cube of the square root of 4x minus 1. The answer is just going to be the same. Whether you leave it in this form or whichever form that you want it to reduce it further, it will just be the same. Now, let's look at the second question. Okay, you are following. I'm now proceeding to the next part of the question. So, the next part of the question was part 2. So, part 2 is saying, they're asking us to find the integral of 4 divided by 5x plus 4 dx. They're asking us to find the integral of the function 5x plus 3 over dx. So now, if you look at this function, it's also a function in a function. Remember that you can rewrite this function as 4 times 5x plus 4 to the power negative 1. You can also write it in that form if you want. Okay, so for this one, maybe before I come to that, this is just the same as 4 times the integral 1 over 5x plus 4. Now, here, we'll let u be equal to 5x plus 4. Then, the derivative of u with respect, because we have substituted 5x plus 4 by u, sorry, we're supposed to have a dx there. Once you make the substitution on that function, that means you need also to change the variable of integration. Once you do the substitution, you need also to change the variable of integration, the x. So the variable of integration should change to u. How can you do that? By differentiating the u. When you differentiate this u, what you're going to get is a 5. And if we simplify, this will mean your dx will be equal to du over 5. Thus, this means the derivative of this function with respect to x is just the same as, which is 4 times the derivative of 5x plus 4 dx. This is just the same as 4 times the derivative of 1 over u, okay, times, where there is dx, we substitute it by du dx. So du over, by du over 5, of which this will mean this is just the same as 4 times the integral 1 over 5u du in that simpler form, of which this 1 over 5 is a constant, so we can have 4 over 5 times the integral 1 over u du. I remember from the basic formulas for differentiation, those standard formulas, if I differentiate u, I'll get 1, which is the numerator is the derivative of the denominator. If you look at the numerator, this numerator is the derivative of the denominator. So it means the integral of 1 over u is just ln of u plus c. Okay, let me put this to be like c1. So this is 4 over 5 times the ln u is equal to 5x plus 4, then plus c1. When you multiply through, what you get is 4 over 5 times the ln of 5x plus 4. So 4 over 5 times c1, this will give us c. Okay, so that's the end of this question. Then what you have done, you have differentiated that function using the substitution method. So your choice of the variable u when you are changing the variable of integration. So substitution method really, it's all about changing the variable of integration. So the substitution method is all about changing the variable of integration. That is just the general part of it. So integration by the substitution method is because you can't integrate using the variable that has been given. So the best thing you can do is you change the variable of integration. In the process, you arrive to make it simpler, and then you arrive at your answer solved as fast as possible. Okay, let's go to the next one, which was I can't really recall what I wrote. The next question was number 3, part 3. Part 3. So let's look at part 3 of our differentiation. Please bear me as a witness because okay, let's look at part 3. Part 3 is talking about the integral of x squared times sine of x power 3 dx. This is now the most tedious situation, that if you don't select your u properly, then you are gone. Your answer becomes wrong, or you find it challenging to arrive at your answer. Now, when you are selecting your u, there's one thing that you should remember. You say, if I select my u to be equal to some g of x, then when I substitute my d of x, which is equal to du either times something or divided by something, which is g prime of x, then what should happen is that where there is d of x, once I substitute it with this du divided by d prime of x, I substitute it here, it should cancel with something here. So this g prime of x, whichever value, whichever kind of a function that will be here, it should cancel with something here that will make my integration simpler. It should simplify your process of integration. Now, if you look at this, let's start first. Let's start. If you look at this question, for example, let's do a trial. If we say let u be equal to sine x power 3, yes, sine x power 3. Now, this means if we differentiate this function, what we are going to get is du dx is equal to, we are going to have 3x squared times the sine, times the cosine of x power 3. Now, what happens? At the end of it, we are going to have dx is equal to du over 3x squared times the cosine of x power 3. Yes, this will cancel. This one will cancel. But now you have sine x power 3 over cos x power 3. Sine x power 3 divided by cos x power 3, it will give you tan x power 3. Again, you are stuck. What is the integral of tan x power 3? Again, you are stuck. You start going back again substitution, of which you really don't know the integral of x power 3, unless if you are very clever. But of which, again, still, you have to use the substitution method again. So you start doing this process repeatedly until you arrive at your answer, which will be so tedious. So this choice will make our work to be long. The best way is we say, okay, if again we let our u be equal to x power 3, x squared, then your du, your du dx will be equal to 2x, so that your dx will be equal to du over 2x. So, okay, when we replace the x by du here, it means this one will cancel. One of these will cancel with x. Still, you're going to remain with x times sine of u, of which, because you're going to have x times sine of u du, that also brings confusion. However, if we let our u be equal to x power 3, then our du dx is equal to 3x squared. This implies our dx, when we solve for dx, what we're going to get is equal to du divided by 3x squared. Hence, if we substitute where there is dx, we substitute du over 3x squared, and where there is x cubed, we substitute u, then what we're going to have is that the integral x power 2 times the sine of x power 3 dx, this is equal to the integral of x squared times the sine of u du over 3x squared. Then the x squared and x squared will cancel. So then we have the integral of sine u over 3 du, of which this one now becomes simpler to integrate, so which will give us 1 over 3 times the integral of sine u du using the constant multiple rule. Now, 1 over 3, the integral of sine u, the integral of the sine function is the negative cosine function of, plus c. When we multiply through, we are going to get negative 1 over 3 times the cosine of u plus c. The c1, but what is u? Negative 1 over 3. What is u? U is equal to x power 3 and plus c. So then you are done with the construction of your solution. Okay. So you are done with the construction of your solution. Okay, let's go to the last one. Let's go to the last one uh, from the list that I gave on the board. The fourth one. Uh, the fourth one, which is the integral of that. So let me just wrap this part. So we are looking at the integral of sine to the power 5 of x, sine x to the power 5 multiplied by the cosine of x dx. Maybe so the question is, which one should be our u? Maybe let me ask, what should be our u in this scenario? What should be your u? Remember, when you are choosing, if you have such a question at your disposal, then they're asking you to differentiate it. One thing that you should recall is what I've just mentioned in the previous example to say, when you are making the choice of u, you should make it in such a way that when you change the variable of integration, the dx, when you make this, you substitute this by du over the derivative of g of x. That the derivative of g of x, which is in the denominator, should at least cancel with something here. Or if it doesn't cancel, then it should give you at least a bigger picture that, okay, this one is going to reduce to this. Okay, now let's look at this. Let's start with this situation. If we let our u equal to the cosine of x, then what will happen? Then our du over dx is equal to the negative sine of x, which implies our dx is equal to du over, okay, is equal to the negative of du over the sine of x, which will not work. This will not work. Reason being, if we put u here, okay, so we are going to put u here, and we substitute this du with negative du over dx, so it will cancel with 1x. So what you're going to remain with is you're going to have the derivative of the negative derivative of sine x to the power 4 times u du. That means we have now two variables, which was not supposed to be the case. So this will not work. Next, we try the other way around. If we say let u be equal to sine of x, if we let u be equal to the sine of x, then our the derivative of u with respect to x to give us the cosine of x, which will mean the derivative of x is just equal to the cosine of, is just equal to the derivative of u divided by the cosine of x. Okay, this one now, at least it will work. Then, thus, the derivative of the sine power 5 of sine x power 5 times the cosine of x with respect to x, this is just the same as the derivative. Remember, where there is sine x, we substitute it with u power 5 times the cosine of x. Where there is dx, we substitute it with du over the cosine of x, of which the cosine of x and the cosine of x will cancel. Then what we're going to have is the integral of u power 5 du, which will give us u power 6 over 6 plus c, but our u, this is equal to sine of x power 6 over 6. Okay, so you are done with your work. Okay, please, if you have questions, you can ask me so that I can respond to them within the remaining minutes. Please, you can ask questions where possible so that I can rush through them. Then we can, so that we can continue. If you have questions for me, please. All those who have questions, please, you can ask questions so that we can continue, we can proceed. And just as a reminder, you need also to go through, this was example number 15. So also go through example number 16. Please also go through example number 16. Okay. So should I continue or you still have some questions? Not really value of u. Basically, your main goal there is about the choice. It's not a u is not a value. U is a function. So in short, like the way you have put it, the main goal is you have to investigate the function u. So there's no really special way on how you can make this choice. You just need to look at the question itself, and then you look at it to say, if my choice, I choose this to be my u, then what will happen to the end result? Am I going to arrive at a situation where I'm able to integrate directly now using the general formulas that we learned? Or is it going to give me another step again that I need again to do the substitution frequently? So you do it twice, thrice, 100 times. So you need to look at that. So your choice for you is not really that unique. It's not unique. What I mean by not being unique is that your choice for you depends to the question. Each question, you can make any choice. So there's nothing like, no, there's a unique formula that I can use to choose you. No. So you just need to look at your question and then you make a choice from there. Yeah, maybe integration by parts. There's a method that I'm going to tell you. Integration by part, there is some kind of an idea that you can employ anyway. There's this idea that you can employ, but also it's not really that unique to some extent. Okay, so let's look at, maybe I can proceed. So we have theorem number 17 and example number 18, but like I mentioned, there are certain examples that I don't really need to bring in. But all in all, let's look at a situation where instead of being given an indefinite integral, remember, if you look at our questions, all our questions were involving indefinite integrals. Now, let's look at a situation where you are given a definite integral, and then they ask you to use the same substitution method for integration. Okay, let's look at this. Now, we have example number 18. Example number 18. So they are asking us to evaluate the integral from 0 to 4 of the square root of 2x plus 1 dx. Okay, so what you're supposed to do is, if the question that you're supposed to ask yourself is, before you substitute these limits, the upper limit and the lower limit, what you were doing first, you were integrating. After integrating, that's when now you can substitute those lower and upper limits. But the question is, can we integrate directly? No. So what we need to do here is, okay, we say, okay, let's look at the solution. So we let our u be equal to 2x plus 1. Then our dx will be equal to du over 2. This stage, I think everyone knows how we are supposed to handle it. Hence, the integral from 0 to 4 of the square root of 2x plus 1 dx is just equal to the integral from 0 to 4 of the square root of u du over 2. So you substitute this, you substitute there, and this is just equal to the integral from 0 to 4 of u power 1 over 2 du over, okay, I can push the 1 over 2 outside. This is equal to 1 over 2 multiplied by u power 3 over 2 over 3 over 2. I think we know what we're supposed to do here. We add the powers by 1 from 0 to 4. Remember, when you are doing a definite integral, the constant, the arbitrary constant c should not be there. Okay, so this is equal to 1 over 2. Now, when we simplify this, this brings us to 2 over 3, u 3 over 2 from 0 to 4, of which we can factor this one out. Then we are going to get 1 over 2 times 2 over 3, so which will give us 3 over 1 over 3. Then we have u to the power 3 over 2, 0 to 4, and this is just equal to 1 over 3 multiplied by u. Now our u here is 2x plus 1 power 3 over 2. Okay. Then please, before you substitute the limits of integration, make sure that you find your u. Okay, make sure that you substitute where there is u. Oh, sorry, 0 to 4. Where there is u, substitute it by the original function, after which then you're going to substitute your limits of integration. So times, we have 2 by 4 minus plus 1 to the power 3 over 2 minus, by using the fundamental theorem of calculus, plus 1 to the power 3 over 2. Okay. So which will give us 1 over 3, and this will give us 9 power 1 over the power 3 over 2 minus 1 to the power 3 over 2 is 1 over 3. 9 to the power 3 over 2 is 9 to the power 3 over 2 is 27 minus 1, which will give us 26 over 3. Okay, so you are done. If you check from your notes, there are 2 approaches that are used. So please, the other approach, you can just study it at your own time and see if you'll be able to produce what I've produced here. So please find time to do that. So having mentioned about the algebraic substitution, let's go to other substitution method. Remember, I mentioned to say there is a method of where you substitute an algebraic expression. There's also another method where you substitute the trigonometric expression. Sometimes where you substitute the other one is the tan function, tan of theta over 2. So now let's look at these other methods of substitution, some examples on other parts of substitution where the kind of substitution that you are making for you is a trigonometric function. So for the first part was some kind of like algebraic substitution where your u is an algebraic function, whether being trigonometric or algebraic, but it's just one and the same thing. So you substitute where there's g of x by u. Now, let's look at some examples where you make trigonometric substitution. But number 2, where you make the trig substitution or the trig identities. So now, what happens is this. Other functions, you can substitute some simple trigonometric functions or rather some algebraic functions, and then you solve your question. But other functions, you need now to bring in the issue of identities, trigonometric identities or hyperbolic identities. So this example I'm doing is a situation, the next examples that I'm looking at is a situation where we use the trigonometric identity substitution. So your substitution kind of You use the trigonometric, this is part 2. You use the identities. Okay, let's look at the example number 20. It is asking us to, one, it's saying determine the integral of sine squared of x. Determine the integral. I know there are 2 questions there, but I'll just write one. Determine the integral of sine squared of x. So determine the integral of sine squared of x. You know, if you look at this question, what is your u then? If we have this question at hand, the question is, what is your u? It will take time for you to find what this u really is until you bring in the concept of identities. You did the Pythagorean identities. You also did other different types of identities. There are a lot of examples which I've put in your notes, a lot of them. I'll look at some of them I'll just leave them like that for you to go through. Once I do this first one, for the second example that I'm going to look at, I'll combine these examples in one example and then I solve them. So please make sure that you go through those examples. Okay, let's look at this example. What you're looking at is you've been given to say find the integral of sine squared of x. Okay, let's look at the solution. If we say let u be equal to sine squared of x, okay, let u be equal to sine x, what's next? Du is equal to, no, let me just say dx will be equal to du over cos x. Even if we substitute that du there, we'll be stuck. We can't cancel that x, cosine x, which is in the denominator, with any cosine of x, which is in the numerator. So it's impossible. Henceforth, if you want to solve this question, you need to bring in trigonometric identities. So I'll just say by trigonometric identities, if you look at sine, the sine squared of x is the same as 1 minus the cosine squared of x. And if you use the double angle formulas, this is just the same as 1 over 2 multiplied by 1 minus the cosine of 2x. As simple. Now, if I substitute, so it means where there is sine squared of x, if I substitute it with 1 minus cos squared of x, that means the integral of cos squared of x, again, I'll be stuck. So the best thing is I need to substitute it with that part. Okay. So now, then, because sine squared of x is the same as 1 minus cos 2x over 2, this means the value that I can get if I integrate the sine squared of x with respect to x, this is just the same as the value that you're going to get if I integrate 1 over 2 multiplied by 1 minus the cosine of 2x dx. Of which this is just equal to 2 over multiplied by the integral of 1 minus the cosine of 2x, everything with respect to x, which is just the same as 1 over 2. Then I'll put that in brackets, the integral of 1 dx minus, using the linearity properties, the cosine of 2x dx. Okay. We continue. So now, the question that we need to ask ourselves now, what is the derivative of cos 2x? What is the derivative of cos 2x? Here, I don't need even to start looking for possible answers, but this is 1 over 2. The derivative of 1, what function was differentiated to give us 1? It is just x plus. If you go back to your formulas, the derivative of cos 2x is, minus. The derivative of cos 2x is sine 2x over 2, then plus the c. So put it as c1 because we're going to multiply by half. And this, when we expand, this will give us x over 2 minus the sine of 2x over 4 plus c. Then you're done with your solution. For the cosine, please, you're going to do it. Okay, like I mentioned, there are examples that I'm going to combine. There are some examples that I'm going to combine. As such, I need your attention as I'll be solving. So I'll combine example number, I need to write it from here. I'm going to combine some of like example number 21, example number 22, we have example number 23, 24, yeah. And yeah, so these examples, I'm going to combine them, and then that will be it. Then I'll look at these other substitution methods. Okay. So this other one, the one that I'm doing here, is a situation where we are using trigonometric identities. So once I do the last exam, the other examples that I've mentioned, which I'm going to combine, then we can call it substitution method is the end. Then I look at where we substitute trigonometric functions. You remember I mentioned last time to say those integrals for inverse trigonometric functions, they are very, very helpful because we are going to use them in under integration. I think I mentioned this. Those who attended my class, those classes, I mentioned this to you. So so let's look at one other examples that involve the same ideas. So so I'll just call it as example 21. Where they are asking us to find the integral of 1 over the cos squared of 2x. Number two, they're asking us to find the integral of sine squared of 3x. Number 3, I think some of these maybe I just need to leave them as exercises though. maybe um okay, let me just do this. It's of great importance, but the integral of 4 times squared of 4x. I hope we are able to follow. There is one which I'm not going to touch, but please, I need, that is example number 24. I would wish you could go through it. Yeah, or maybe let's do it. But I'll be fast when explaining because you already have these notes. Sine. Okay, I'll do 1, 3, and 4. For this one, it's similar to the ideas in here. Or if I do 2, then you can do the last one, which is number, oh, if I do 4, I 2, then you can do number 4 because the concepts are the same. That's why I'm saying the ideas are just the same. So of which I don't need really to start going through each of them one by one. Instead, you're going to find time to go through them yourselves. Okay. Now let's look at the first example, which is 1 over cos squared of 2x. Let's look at the solution. Let's look at the solution. Okay. The integral 1 over the cosine squared of 2x dx, this is the same as the integral of sec squared of 2x dx. Remember, the reason being because since 1 over cos x is equal to sec x. Okay, this is the scenario why it's like that. So this is equal to now if you go back to your last sessions about integration, now because we are at this stage, I think it becomes a bit challenging to understand, to say we have a 2x here, but then how can we now go ahead and do the integration? So when we apply substitution by algebraic substitution, let u be equal to what? 2x, then our dx will be equal to du over 2. Okay. So if this is the case, then the integral 1 over the cos squared of 2x with respect to x, which is equal to the integral of sec squared of 2x with respect to x, this is equal to the integral of sec squared of u du over 2 which is just equal to 1 over 2 the integral of sine squared of u du. What function can you differentiate and it will give you sine squared of x? It's the cosine function. I mean, it's the tangent function. So this is equal to 1 over 2 times the tan of u plus c1. So when you differentiate tan u, you get sine. Oh, sorry. It is not sine sec squared of x. So, but our u, so this is 1 over 2. The tan, our u is 2x plus c. Then you are done. So what you have done, you employed the idea of trigonometric identities, of which 1 over cos theta is sec theta. Okay. Now let's go to the second one. The second part also, let's go to the second part. So here, the kind of substitution that you are doing, the kind of ideas that you are employing is the idea of trigonometric identities. So it's the idea of trigonometric identities. So this is the idea that you are employing in solving the question. Now let's go to the next question, which involves, they're saying find number 2, the sine squared of 3x dx. Now, from trigonometric identities, by trig identities, by trigonometric identities, remember that the sine squared of x is equal to what? If you can recall, is equal to 1 minus the cosine squared of x, which we gave as 1 over 2 multiplied by 1 minus the cosine of 2x. Isn't it? Then, by trigonometric identities, this is the scenario. Then, what does this mean then? This means that the sine squared of 3x will be equal to 1 over 2 multiplied by 1 minus the cosine of 6x. This is what. That's if this is the case, then that is other trigonometric identities. This one, please, you can go back to trigonometry if you want to verify. That's the integral of sine 3x or 3 with respect to x. This is the same as the integral of half multiplied by 1 minus the cosine of 6x with respect to x, which is the same as half times the integral 1 minus the cosine of 6x dx 1 over 2. By linearity, we are going, the integral of 1 is x. The integral of cos 6x is uh, the sine of 6x over 6 plus C1. When we multiply through, we are going to get x over 2 minus the sine of 6x over 12 plus c. Then you are done with your construction of that derivative. Please and please and please make sure that we go through this. Otherwise, if we don't go through them, then we have challenges. I can assure you. Make sure you go through this. You might find it put in the test and then you start struggling because you didn't go through it. No matter how much you could see to read to be like an example, why don't I just come and start mentioning, no example, this, have you seen the solution? That's the solution. I come here, I start explaining one by one. So after the explanation, what you're supposed to do is you go through it, try to solve it. Try to solve that question manually. Not you just start reading through as if you're reading a novel. No, this is maths. In maths, we don't read, we study. When you study the concept, you solve. Okay, so let's look at the last one, but not the least. I'll look at the last part, which involves the so the last one I'm going to look at is the integral 4 times the tangent of 4x dx. It is squared. Now, by trigonometric identities, I think if you recall, the tangent of x will be equal to the sec squared of x, the sec squared of 4x minus 1 from the trigonometric identities. This is from trigonometric identities. Hence, if you can't recall the trigonometric identities, I can assure you are going to have challenges to solve this question. The integral of 4 times the tan of 4x squared, the square of the tan of 4x, this is equal to the same, I can put outside 4, that times the integral, where there is tan squared of 4x, we substitute by that, we can have the sec squared